So they want us to graph the function and then state the domain and range. And this is our equation. Y equals log base 1/3 of x minus 1. Now they did not put that x minus 1 in parentheses, which means that this is a k value. Okay, so really another way I would write this is log base 1/3 of x in parentheses minus 1. Okay, so if I go through and identify then what is b, what is h, and what is k, well, my b is my base value, so b is 1/3. If there's nothing in the parentheses with x being added or subtracted, that would mean h would have to be 0, which means my k value is -1. Okay, all right, and we're going to follow 4 steps when we do these graphing problems. So step 1, and I would make sure to write all of these down because we're going to try and do this every time for this lesson. When we graph, we're going to identify the vertical asymptote, which we already wrote down is the line x equals h. So for this problem, we said h is 0. My vertical asymptote is x equals 0. And I'm just going to switch colors. So my vertical asymptote is the line x equals 0, okay, which we'll draw here when we get to our graph. Step 2, we are going to set x minus h equal to 1, and we're going to set x minus h equal to whatever our base number is, okay, and solve for x. Because those are going to give us the easier values of x to plug in and use when we're finding our 2 points. So again, my h value is 0, so if I set x minus 0 equal to 1, and if I set x minus 0 equal to my base number of 1/3, well, that's pretty easy to solve for. We get x equals 1 and x equals 1/3. That's going to be used when we go on to step 3, which is make a table of values. And solve for y. And when I say make a table of values, we're just using the 2 values we just got for x. So I'm going to set up x and y. I'm plugging in 1, and I'm going to plug in 1/3, but we're going to start with 1. If I plug in 1 for x into my original equation, we're going to get log base 1/3 of 1 minus 1. If I'm solving for that, if I'm trying to evaluate that to figure out what y is, well, we know, right, I'm taking a log base 1/3 of 1. We know our special log rules, or one of our special logarithms is the logarithm of 1, where anytime I'm taking a log of 1, my answer is 0, right? So this piece of it, if there's a 1 here, no matter what the base is, evaluates to 0. Now, we do still have that minus 1 there after it that has nothing to do with the log. We do that after we take the log of base 1/3 of 1. So I still have to subtract 1, and I'd get a y value out of -1. So the point we just found was 1 that I plugged in for x, and I got out -1 for y, and we'll graph that here in a second. The second value I'm plugging in is log base 1/3 of 1/3, right? We're plugging in 1/3 for x, minus 1. Again, if I evaluate my log first, this really means 1/3 to what power gives me 1/3. That's our other special log rule, our log of base b, that says if I've got the same base value in my log as the number that I'm taking a log of, which I do, right? Both of those values are 1/3 here. That's always going to evaluate to 1. So this is going to become 1, and then I still have that minus 1 at the end. So we just found the point. I plugged in 1/3 for x, got out 0 for y. So now I've got 2 points and an asymptote, just like with my exponential graphs. So I'm going to plot those 2 points, and I'm going to draw my asymptote at x equals 0. So step 4, is really just finish the problem or plot the points and the asymptote and draw the curve. So they've done that already here for us, but just to kind of get a better picture of what we're doing here, if I were to plot the point 1, negative 1, that happens right here, the point 1/3, 0. They've got that graphed here. If I were to draw my asymptote at the vertical line of x equals 0, that's where my asymptote would be. Okay, draw your curve just like we were drawing our curves with exponential graphs. They're just oriented differently now because this is an inverse to an exponential graph. And then we want to draw our curve through those 2 points and show that it gets really, really close to the asymptote but doesn't cross it. Okay, and then it does ask for domain and range. I did emphasize this in the first part of the notes, but our range is all real numbers. Just like with our exponential graphs, our domain was always all reals. With our logarithmic graphs, my range is going to be all real. Okay, remember, domain has to do with x values, range has to do with y. So if we're looking at what x values are covered here in this graph, well, this side of my graph is going to go forever to the right? It's going to cover all the positive values of x. But as I curve to the left, there is a boundary there at my asymptote, right? There are x values that we're not going to reach. I'm never going to cross the line x equals 0. So everything that gets graphed in terms of my x values, all of those x values on that curve are going to have a coordinate or an x coordinate that's greater than 0 because everything's graphed to the right of 0. Okay, my range is my y values. Now, that's our vertical axis. We can see my graph is going up forever, so it's going to graph all the positive values of y. And even though it's happening a lot more gradually, it is going down forever, right? There is a downward curve. So even though it's really slowly going down, it's still would eventually cover all of our y values that are negative as well. So my range is all real numbers. You should never have to think about range for logarithmic graphs because it's always all reals, the same way that domain was always all reals for exponentials. Okay, we're going to do one more of those. Okay, log base 5 of x plus 2. So again, here's our formula. We've got y equals log base b of x minus h plus k. If I identify what my base is and what h is and what k is here, well, my base is 5. My h value, we always have to flip, is going to be negative 2. And my k value, since there's nothing added or subtracted at the end, is going to be 0. All right, so step 1, just like last time, we're going to identify my vertical asymptote, which is the line x equals h. So my vertical asymptote here is going to be x equals negative 2. So I'm going to have a vertical line through where x is equal to negative 2 on my graph. Step 2, we are going to set x minus h equal to 1, and we're going to set it equal to the base number and solve for x. So I'm going to set x plus 2 equal to I set x plus 2 equal to 1, and I'm going to set x plus 2 equal to my base number of 5, and then I'm going to solve for x. So I'd have to subtract 2 here, we'd get x equals negative 1, subtract 2 over here, we get x equals 3. Those values are what we're using for our table of values in step 3, what we're plugging in for x to see what we get out for y. So if I plug in negative 1, we would get log base 5 of 1 plus 2. Well, that's going to simplify to log base 5 of 3. Or sorry, that should be a negative 1. Back up. Log base 5 of negative 1 plus 2, which is going to give me log base 5 of 1. And now we're back to a log of 5, or sorry, a logarithm of 1. Anytime we take a log of 1, we know that our answer is going to be 0. So we just found the point -1, 0. Then I'm going to plug in x equals 3. So I'm going to have log base 5 of 3 plus 2, which is going to give me log base 5 of 5. Now we've got our special log rule where I've got a log of base b of that same value of b. That's always going to evaluate to be 1. So we just found the point. I plugged in 3 for x, got out 1 for y. And then we're going to draw a graph. So I'm going to draw my vertical asymptote at x equals -2. Draw my points. We've got a point at -1, 0, and we've got a point at 3, 1. Draw my curve through those 2 points and approaching the asymptote. We should get something like that red line there. My domain, all of my x values are graphed to the right of that asymptote, so it's x is greater than -2, my asymptote value. And my domain is all reals, or sorry, my range is all reals. Okay, but that is it for this lesson. Your homework is the worksheet for 8.4, and I will see you guys next time.